Okay, we are going to graph cosecant. Remember, cosecant is the reciprocal, 1 over sine. So the first thing you're going to do is you're going to graph sine x, and that's what's represented here with this dotted line. That would be your sine x curve. You're going to do any transformations that you need to do to sine x. Remember, this is that midline, and these are the points beginning, middle, and end of sine are on the midline. And then amplitude up, amplitude down. So you're going to graph sine x. I'm going to try to do it in light gray. You guys should do it in light pencil or as a dotted line, just like it is here. Then remember, if sine x equals 0, the reciprocal, cosecant, is 1 over 0, which is undefined, right? You can't divide by 0. When something is undefined, that gives you an asymptote. So we're going to do what we like to call, rip it and flip it. You rip it at the zeros, because if it touched the midline, that's called a 0. And if it was a 0 as an original function, it is undefined as a reciprocal function. So that's going to give you your asymptotes. But if sine x equaled 1, the reciprocal of that is still 1. And if sine x equaled -1, the reciprocal of that is still -1. So those points are actually points on your cosecant curve, and everything gets flipped over. So this curve, the little yellow curve that was facing down, now becomes this red curve that's facing up. This section, that yellow curve was opening up, now it is this red curve opening down. And the orange asymptotes and the red curves are the actual cosecant graph. The light yellow is just how we got there. Okay, so same idea for secant. So we'll graph, for the parent graph, our midline is at 0. So you would graph your midline first. Secant is the reciprocal of cosine. So you'll graph your cosine curve lightly or in another color. Cosine touches the midline, has zeros here and here. When you rip it and flip it, anything that touched the midline now becomes an asymptote. You rip it at the zeros. And then the top of your cosine curve and the bottom of your cosine curve are actual points on your secant curve. Rip it, and now I'm flipping that yellow curve over. If it was opening up, now it's opening down. Again, this is just one period, so this would repeat over and over again, but if you do that, you can't tell the difference between secant and cosecant, so we will graph one period. Notice down here, secant and cosecant have no amplitude, because this is not a hill or a valley. They kind of look like parabolas. Understand that they aren't. But they are not hills and valleys, so they do not have an amplitude. You can't measure a hill that goes on forever. So instead, you will give the vertical transformations. Okay, here we go. So the nice thing about today's video is you can practice graphing sine and cosine while we practice secant and cosecant. So I'm going to switch to light gray. I don't want it to be too light. I want to make sure you guys can see it. So actually it's going to be kind of dark gray. We're doing two cosecant. The reciprocal of cosecant is sine. So I'm going to change it to a sine equation and graph that first. So for sine, so I'm sticking to gray, the amplitude, the period, the phase, the vertical, and then beginning and end. See how many of those you can answer? Pause your video and answer those. So the amplitude is the number in front, 2, positive. The period is 2 pi over b. B is an imaginary 1, so 2 pi. The phase shift is right pi over 4. Vertical shift is down 1. This has no vertical reflection. So my beginning is going to be pi over 4, and my end is going to be pi over 4 plus 2 pi, or pi over 4 plus 8 pi over 4, which is 9 pi over 4. So I'm going to set up my axes. It's right pi over 4, so I can hug over here. It's down 1, so maybe here. My axes should count just like my beginning and end by fourths. 1/4, 2/4, 3/4, 5, 6, 7, 8, 9/4. That worked out nicely. Label one of them. Your y-axis counts by ones. Here we go. The midline, the vertical shift, is down 1. So there's a dotted midline down 1. I was making that green before. I'm sticking with gray because this is all just to get the cosecant graph. At my beginning point, pi over 4, sine is on the midline. So pi over 4 is on the midline. Pi over 4 is on the midline. At the end point, 9 pi over 4, that is also on the midline. In the middle of sine, that is also on the midline. Then the middle of those segments, you instantly do the amplitude. So the middle is here, and the amplitude is 2, so 2 up. The middle of this one, 2 down. And lightly in pencil, right? That's why I'm doing mine in gray. This would be the sine curve. Try to hit your points. That's going to help me get the cosecant. So this is not the answer. We're all clear on the fact that this is not the answer? Okay, so we're going to rip it and flip it. Where your points hit the dotted line, those are your zeros. That's what makes the equation 0, which would make cosecant undefined. So you rip it at the zeros. And then you flip it over. This point is an actual point, and it's 2 parabola-ish, but they don't get wider and wider, right? That's not a parabola, but 2 going up, and this point was actually a point, and this side is now going down. And the red part is cosecant. Okay, I just added a bunch of answer blanks. So these answer blanks are for actual cosecant, the equation we were asked to graph. Some of them will be the same, but I wanted you to notice, for example, there is no amplitude for cosecant. Instead, based on the equation, we say it was stretched vertically. Technically, because that says vertical transformation, we can just say stretched. It had no vertical reflection because A was not negative. Its phase is still right pi over 4, and its period is still 2 pi, just like the gray answers. But the vertical transformation is what they will ask, not amplitude. If they ask for amplitude, the answer is does not exist. If they ask for amplitude, the answer is does not exist. Okay, domain, range, min, and max. We're going to skip around a little. Let's do min. Here's the complicated part. I understand this point is lower than this point. But the question is relative min. Relative mins are bottoms of a valley. My red curve, that's the bottom of a valley. So that's the answer to relative min. On the red curve, this one is top of a hill. That's the answer to relative max. Students get that confused a lot. So you're not looking for which point is higher, blue or purple. It's compared to the red points right around it. The blue one is a relative min, and the purple is a relative max. So the blue one, we were counting by fourths, right? 1/4, 2/4, 3/4. Remember, it's a point. 3 pi over 4. But it repeats every period, 2 pi n, comma, and its y value is at 1. See if you can do the relative max the same way. We were counting by fourths, so 4, 5, 6, 7/4. It's going to repeat every period. And its value is -3. So get used to the fact that your relative min might be higher than your relative max. Okay, this one's asymptotes is what I want to do next. I always do the first asymptote on the left side of the graph, but obviously there's 3 to choose from, and technically there's an infinite number of them. The one on my left is x equals. It goes through pi over 4, and it repeats. There's one right in the middle of my graph, right? So it repeats every period over 2. And if I put 2 pi over 2, that's just pi. It repeats every pi n. So my domain, now I'm going up to domain on purpose, is all real numbers except x cannot equal my asymptotes, pi over 4 plus or minus pi n. Okay, range, lowest to highest. The lowest this graph goes is negative infinity. But then it comes up to that relative max, negative 3. It touches it, bracket, but then it stops there. Then it starts over at the relative min, which is 1, bracket, and goes off to infinity. Even, odd, neither. This has a vertical shift, so it cannot be odd. And my min or max is not going to line up on the y-intercept, so this one is neither. So this is our first example of cosecant. Okay, number 4. Though I'm not exactly sure why it's number 4. We are doing secant, so we will start in gray. Reciprocal of secant is cosine, and also this is not in graphing form yet. See if you can put that in graphing form correctly. So you need to factor out the 1/2. When you take a number and divide by 1/2, remember you're multiplying by 2, so this is going to be 6 pi. Double check. Half of 6 does give me 3, so that is correct. So this is what we're going to graph first. I'm going to do some answer blanks in gray. You guys should be getting better at this, I hope. Pause the video and see if you can answer all of these. When you unpause the video, my gray answer blanks will be filled in. Okay, so did you remember that amplitude is always positive? Hopefully you put +1 in that answer blank. But because the A was negative, it does give you a vertical reflection, yes. Period is 2 pi divided by 1/2. When you divide by 1/2, you really multiply by 2, so the period's 4 pi. Phase is left 6 pi. Vertical shift is up 1, so it's going to begin at negative 6 pi and end at negative 2 pi. So everything's in the negatives. So our y-axis should be way over here. That's good. And then -6 to -2, and it's going up 1. So maybe right here seems like a good spot. I need to leave myself enough room to get from 0 all the way to -6. So I think I can go by 2s. -1, -2, -3, -4, -5, -6 pi, -pi. Y-axis counts by 1s. Remember, I'm doing this in gray or light pencil because I'm not graphing the answer yet. I'm just graphing cosine. So vertical shift, midline, up 1. That's that green line, but I'm just sticking with gray today. Beginning point, -6 pi. But we're graphing cosine, and cosine instantly does the amplitude. So down 1 from the gray line, -6 pi at 0. The end point, -2 pi, also instantly does the amplitude. Those line up. The middle of that does opposite A, so up 1. The middle of those are on our midline. In light pencil or in a dotted fashion, this is cosine. Now we're going to rip it and flip it. Where cosine hits the midline, that would be 0, so that makes it undefined when we do the reciprocal. So we rip it at the midline. And then every point other than that is an actual point of secant, and you flip it. Actual point, flip it. Actual point, flip it. Again, it continues. It would do this, and then it would do this again, but we're just graphing one period of secant. Okay, so there's the answer blanks for our secant graph. Pause the video. You should be able to do these on the left first, so next time you unpause the video, those answers will appear. Okay, an A value of 1 does not stretch or compress a graph, so there is no vertical transformation. But an A value of -1 does reflect it vertically. The period is the same that we figured out earlier, 4 pi. Left 6 pi and up 1. Okay, let's do min and max next. Remember what I told you about min and max? It's compared to the points right around it. So if I could zoom in really, really close, where would the relative minimum be? See if you can do min and max. Pause your video. Okay, so the relative minimum is that one in the middle, the blue one. It's at negative 4 pi, but it repeats every period. So this number, here's my period answer in yellow. This number is the period. And it's a point, so it's that, comma, 2. And then the relative max is the purple one. Again, I always choose the furthest left one that we graph, but obviously there's 2 choices. Technically, there's an infinite number of choices. It happens at negative 6 pi plus or minus 4 pi n, and its y value is 0. See if you can write the equation of the asymptotes. Again, I'm going to grab the furthest left asymptote. So if you want to compare yours with mine, what is the furthest left asymptote? So asymptote vertical is x equals. It's not a line without an x or y equals, but a vertical asymptote is x equals. That is going through negative 5 pi. And there's 2 of them in my graph, right? So that repeats every 4 pi over 2. 4 pi over 2 is 2 pi. So it repeats every 2 pi n. So for the asymptotes, it's period over 2 because I see that the distance between them is half the period in length. So then see if you can do domain. Remember, you need asymptotes in order to do domain. What x values does this touch? Well, it touches all of them, all real numbers, comma, and then x cannot equal your asymptote, negative 5 pi plus or minus 2 pi n. Range, the lowest it goes is negative infinity, and then it pauses at 0, but it does touch 0, so that's a bracket. Then it starts again at 2, bracket, because it touches it, comma, it goes on to infinity, parentheses. If you trace this back, you can see our relative min. So I'm looking at my relative min equation, right? Negative 4 pi plus 4 pi is going to give me 0. So I will get another relative min on the y-axis. When that happens, it's going to be even because it's symmetrical. This is an even equation. Okay, we will practice more of this in class, but that is it for today. I hope you guys are doing good.